Hey Finxters! Now in today's lecture, we will be learning how to create a two-dimensional array in Python. We can see that 2D arrays are used almost everywhere. As simple examples, you can think of a chessboard or eggs arranged in a rectangular egg holder are 2D arrays. Now even in programming, 2D arrays are used almost everywhere. For example, 2D arrays are used in image processing, surveys, speech recognition, geoscience, tables, databases, graphs, you name it and you have it. Hence, it is very important to understand the basics of 2D array, and in this lecture, we will do exactly that. We will learn how to create a two-dimensional array. So this right here on the screen is an example of the two-dimensional array. You can also call it a matrix. So a two-dimensional array is an array of arrays. That is, it is a nested array which has two dimensions. So what is a dimension? A dimension is nothing but a single level of depth in an array. So 2D arrays have two dimensions means that they can grow or shrink vertically as well as horizontally. So these dimensions can be represented as rows and columns. So this grid right here, which you can see, has rows as well as columns, and these rows and columns come together to make a particular cell within the entire grid or the entire matrix. So this element 1 is stored in a cell which is given by row 0 and column 0. So we will come to that in a while. The point here is to understand how a 2D array looks. Thus, it is quite clear from this illustration that every 2D array has two indices, one corresponding to the row and the other corresponding to the column. So this right here, 0, 0 represents row 0, column 0. 0, 1 represents row 0, column 1. And 0, 2 represents row 0, column 2. Similarly, 2, 0 here, which has the element 7, represents row 2, column 0. So this one, 147, this is column 0. Then this 258 is column 1. 369, this is column 2. Similarly, 123 is in row 0. 456 is in row 1. 789 is in row 2. So this diagrammatic representation of a matrix should make things clear. And let's say I want to access the element 6. So what would be the row and column for this element 6? Yes, it lies in row 1, column 2. So this is how the indices of a matrix or a 2D array are numbered. Now, when you try to write a program, then this is how the array will look like. It has the elements 1, 2, 3 within a list. Then the elements 4, 5, 6 are within another list. And the elements 7, 8, 9 are within another list. And all these three lists are stored within an outer list. So please note that this structure is very important as we move ahead. Now that you have a clear picture of how nested lists can be used to denote a 2D array in Python, let's find out how we can create a 2D array, and then we shall learn how we can assign values to this array. Now, when I mentioned that how we can create an empty 2D array, that means I'll create a 2D array which will be loaded with zeros. So let's go ahead and find out how we can create a 2D array with the help of a nested list. So before we dive into the code, here's an illustration which explains how the code will work. Let's say that we want to create a 2D array which will be loaded with zeros, and that array will have 3 rows and 2 columns. Now, in order to create this array, we need an empty array which is arr underscore 2D, which will store the entire array. That is, it represents the 2D array itself. Now we need to take the help of couple of loops. The outer loop will help us to generate each row, while the inner loop will help us to generate the values within every column. Now don't worry if you are a bit confused. Illustration that you'll have a look at in a while will make things quite clear. So as we move inside our outer loop, we go ahead and create another empty list which stores the values in each column. Then we have our inner loop. Now please note that this right here, the indentation is not correct. It should be the inner loop. It looks as if both the loops are outer loops, but no, this is the outer loop, whereas this one right here is the inner loop. So the indentation is not correct here. When I explain this in the PyCharm IDE, you'll have a look at it and you'll understand it better. But now just have a look at the concept. Once the concept is clear, we will not have any difficulty in writing the code. So within the inner loop, we go ahead and append 0 to each column. Once 0 has been appended to each column, then we come out of the inner loop and we enter the outer loop, and in the outer loop populate the row of the matrix. So this process gets repeated until we finish populating each cell of the matrix, and then we simply print the 2D array which is loaded with zeros. I know you are confused. So let's have a look at this illustration. So let's say we are inside our inner loop. So in the first iteration of the inner loop, that is this one, 0 will be appended to row 0, column 0. After that, in the next iteration of the inner loop itself, the value at row 0, column 1 will be populated. Then finally, in row 0, column 2, the value 0 will be populated. So as you can see that the row here remains constant, but column values keep changing. So after this, we are done with our inner loop. And now it is time to populate the entire row. So what happens is that all these values get stored in ARR underscore 2D. So now we have the first row of our matrix. So now we are done with the first iteration of the outer loop, and now we move on to the next iteration. Once we move on to the next iteration, we are once again inside our inner loop, and now these are the values that will be populated. 0 will be populated in row 1, column 0. Then once again 0 will be populated in row 1, column 1. And then 0 will once again be populated in row 1, column 2. So once again the row remained constant, but column values were changing one by one. So after all these values are populated in the respective cells, we are done with our inner loop, and then we go ahead and store all these values in the second row of our matrix. Then we move on to the third iteration of our outer loop, and as soon as we move inside the outer loop, we encounter the inner loop as well. So within the inner loop, once again 0 gets appended to row 2, column 0, then 0 gets appended to row 2, column 1, finally 0 gets appended to row 2, column 2. And then once again all these values get appended to the third row of our matrix, and then we are done with all our iterations, and we finally print this as an output. Now please note that in this example we have 3 rows and 3 columns, not 2 columns. These are 3 rows and 3 columns. So this is how this piece of code works. Now let us go ahead and have a look at this with the help of a program. And with the help of that program, I hope the entire concept will be clear. So let's say that we want to create our 2D array which has 3 rows and 3 columns. Now let's go ahead and create the empty list ARR underscore 2D. So this is the array within which we will be storing the zeros. Now this is an empty array as of now, but once we are done with it, 3 lists one by one will be added to it. Now it is time to create our outer loop. So we will iterate across all the rows in our array in the outer loop. We also need an inner loop with the help of which we will iterate across the columns. Now if you remember, we also need to create another empty list which will store the values that are being stored in each column or in each cell of the matrix. So let's name that column underscore elements. Within this, we will store the values one by one. Now let's move inside our inner loop, and all we have to do is append the value 0 to our list column underscore elements. So let's append 0. Now once we are done with the inner loop, we now need to go ahead and store the entire row as we saw in the illustration previously into the first, second, and third rows of our matrix. So to do that, we simply go ahead and use our list ARR underscore 2D and append the array column underscore elements within this array. So in the first iteration, the first list will be populated with the help of this line. Then in the second iteration of the outer loop, the second row will be populated with the help of this line. Finally, in the third iteration, the third row of the matrix will be populated with the help of this line. So that's it. Now let us simply go ahead and print our 2D array. So print arr underscore 2D. So that's it. That's how simple this is. Now let's go ahead and execute this. And there we go. As you can see, this is the exact array that we wanted, and we have successfully declared an array loaded with zeros with the help of nested lists. So now I hope that this method is clear and you can easily use it to create a 2D array. Now this can also be done with the help of single line of code, and to do that we will take the help of a list comprehension. So let's say arr underscore 2D is our 2D array. And now we need to create a list comprehension. And within this list comprehension, we first need to define our inner loop. And within this inner loop, we will simply tell Python to insert 0 within the range of the columns. So let's say that the number of columns is 3. So we will ask Python to insert 0 within each cell. Now this was our inner loop. We also need to take care of our outer loop, which stores all these values within the entire row of our 2D array. So to do that, we'll say for y, that is this value is in y in range. And now we have to define the number of rows that we have. So what are the number of rows? It is 3. So this essentially means that the outer list gets created, then 0, 0, 0 get appended in the first iteration of the inner and outer loops, then 0, 0, 0 gets appended in the second iteration, and finally 0, 0, 0 gets appended in the third iteration. So that's a one-liner for you. Now let's simply go ahead and print our arr underscore 2D, and let's see if this works. And yes, it definitely works. So you can see that we have optimized our entire code in a single line. Now, many of you might find this confusing. Hence, I explained the first method elaborately, and then I went on to explain this method. Okay, with that, we come to the end of this method. Now we will be talking about one of the most important libraries in Python known as Numpy. If you are dealing with arrays, be it a 1D array or a 2D array or n-dimensional array, Numpy is the library that will help us to play around with every kind of array. It is a library within Python that has been specially designed to play around with arrays. Hence, without further delay, let us have a look at how we can use the Numpy module or the Numpy library to create a 2D array. Also, you will be happy to know that the Numpy library supports a lot of functions that can be used to perform operations on array, like matrix multiplication, transpose of a matrix, matrix addition, etc. In fact, Numpy has a whole submodule that is dedicated towards matrices known as numpy.mat. But as you know, that Numpy is an external library. Hence, you first have to import Numpy. So let's go ahead and do that. Let's import Numpy as NP. Now, NP is the abbreviation that we are using to represent Numpy. So let us go ahead and create a 2D array loaded with zeros. And do you know how many steps we need to create this array loaded with zeros? It is only a single line of code that will help us to do that. And in this case, we do not have to use any comprehensions or any difficult concept. We just have to use a single method known as numpy.zeros. So the name of that method is numpy.zeros. So what this method does is that it returns a new array of given shape and type filled with zeros. So if you have any doubt, let us go ahead and let's have a look at an example and things will be crystal clear. So we have already imported our numpy module. Now let's go ahead and let's say that the name of our array is arr underscore 2d. And now we need to use our numpy module. So np dot, and then we simply need to use the method zeros. And within this, we simply need to pass the shape of our array. So let's say that we want 3 rows and 3 columns. So let us go ahead and print arr underscore 2d. Now let's check. Oops, it is the first argument which holds the shape of the array. The second argument actually stores the desired data type of the array. So when I mentioned 3, 3, Python thought that the first 3 is the shape while the second 3 is the data type. So it threw an error that it cannot interpret 3 as a data type. So let's wrap this within brackets and let's say that we want to have 3 rows and 3 columns. Now let's execute this and this should work. And there we go. So this is exactly the array that we wanted. Now, if you want to load your array with ones instead of zeros, Numpy also has a provision for that. That's how amazing this library is. Instead of zeros, you have to use the function ones. And that's it. The entire syntax remains the same. Now let's go ahead and execute this to find out what happens. And there we go. As you can see that now we have an entire array loaded with ones. So that's how simple it is to create an array with the help of NumPy. Now let's say that you want to assign different values to different rows. So let's say that you want to change the value at row 0, column 1 to 5. And you also want to change the value at row 2, column 2 to 5. So you can do that with the help of the following syntax. You simply need to go ahead and access your ARR underscore 2D array. Then you need to access the particular cell with the help of its row and column numbers. So this right here is row 0, column 1. So let's access row 0, column 1 like this. Let's assign the value 5 to it. Similarly, we also want to assign 5 to the cell which is given by row 2, column 2. So all you have to do is change this to 2, 2. And that's it. Now let's execute this piece of code to find out what happened. And there we go. We have successfully changed or assigned different values to the respective cells. Now this should make it clear that how you will access the values at a given index. It's quite simple. Let's say that you want to access the value at row 1, column 1. So to do that, you simply need to go ahead and use the print statement and access the value with the help of its row and column indices. So this lies at row 1, column 1. Now let's see if we have 1 as the output or not. And there we go. 1 is exactly what we wanted. Now let's say that you want to convert these data types to integers. These are floating point values. So would you be able to do that? Yes, definitely. I just mentioned a few moments ago that the second argument for this method, let's say this is zeros. Let's not populate it with ones. Let's populate it with zeros. So the second argument accepts the data type. And to specify the data type, the argument is D type. And here you have to mention that the data type, which is D type, has to be equal to int, that is integer. Now these values are going to be integers. So let's see if this works or not. And there we go. Now these values are no longer floating point numbers. These are integer values. So I hope that the np.zeros method quite clear, and now you can use it to create 2D array as well as access the elements from the 2D array. Well, NumPy has numerous ways using which it helps us to create an array. And the next method that we will be learning using NumPy is known as the array method. So that also helps you to create an array. So let's say that we want to create an array using the array methods. So you have to use np.array. And then within this, you have to pass the values as list. So we have our outer loop and then we have our inner loop. Let's say we want to pass the value 0, 0, 0 in the first list, then 0, 0, 0, and finally 0, 0, 0. So we have successfully populated all the zeros in the first, second, and the third list. So that's it. Now let's go ahead and simply print this ARR underscore 2D array. Now let's see if this works or not. And there we go. We have successfully populated our array with zeros. What you can also do is that you can go ahead and create this list and then convert it into an array. So let's say li is equal to this list, and then you pass this list within the np.array method, and this will also work for you. So there we go. This also works. And accessing the elements is once again similar to the way we saw previously. So let's say that we want to change these values. That is the value at row 0, column 0, then the value at row 1, column 1, and the value at row 2, column 2 to 5. So how do we do that? We simply go ahead and take the name of the array, which is arr underscore 2d, and then access the element at row 0, column 0, and then assign the value 5 to this cell. Let's do this for the other cells as well. So the other cells are row 1, column 1, to which we want to assign the value 5, then row 2, column 2, to which we want to assign the value 5 once again. So that's it. That's how simple this is. Now let's go ahead and execute this piece of code. And there we go. We have the array that we wanted. We have successfully assigned the values to the respective positions by accessing the row and the column index of the array. So that's how effective Numpy is. With that, we come to the end of this lecture. I hope it helped you. If you have any doubts, please mention them in the comments below, and I'll try my best to answer all your queries. Goodbye.